Energy sources. Sources of electrical energy or active elements. So already I have told the examples of active elements are voltage source, current source and operational amplifier. So these are all active elements. So voltage source and current source are active elements. We can split this voltage source and current source into two types. One is ideal voltage source, another one is practical voltage source. Current source can be divided into two types, ideal current source and practical current source. So these are all two types of voltage sources. So we know that voltage source and current source are active elements. Ideal voltage source. So ideal voltage source means the voltage source is ideal. We don't have any internal resistance. So listen, here we have a voltage source. In this voltage source, we does not connect any resistance. So we can have Rs is equal to 0. That is, internal resistance is not connected. Okay, and V is the output voltage. The current I flows due to the voltage source. So here the output voltage does not depend on the current which is delivered by the voltage source. Does not depend. The output voltage does not depend on the current. That is called ideal voltage source. So here in this ideal voltage source, it has zero internal resistance and it delivers the energy at a specified voltage which does not depend on the current delivered by the source. In ideal voltage source, we don't have any internal resistance. So we can call zero internal resistance. The output voltage does not depend on the current delivered by the voltage source. So we can draw like this. Because Rs is equal to 0. So V depends only on the V, does not depend on current. Okay. So this is called ideal voltage source. So this is the graph. This is the graph for ideal voltage source. Here, listen here. We have drawn the graph between the relationship between voltage and current. The output voltage V does not depend on the values of current. For I1 is equal to 0, for I2 is equal to 0, the voltage is constant. The output voltage does not changes, does not vary. It is constant for all the values of I. That means the output voltage V does not depend on the current delivered by the voltage source. So here I have written the KVL equation, Vs minus B is equal to 0. Therefore V is equal to Vs. So output voltages depends only on the voltage, does not depend on the current delivered by the voltage source. So that is called ideal voltage. Practical voltage source. Practical voltage source means it has a finite internal resistance and it delivers the energy at a specified voltage which depends on the current delivered by the source. So practical voltage source, in this practical voltage source we have a internal resistance is present. Therefore, the output voltage produced by the circuit depends upon the current I delivered by the source. That is called practical voltage source. So here I have written the KVL equation for this circuit. So Vs minus I into Rs minus V equal to 0. Therefore V is equal to Vs minus I into Rs. So in this case we have the current is subtracted from the voltage source. Therefore the current is reduced when voltage is increased. That means the voltage depends upon the value of current which is produced by the voltage source. So practical voltage source, the output V depends upon the current delivered by the source. So here this is the graph drawn between V and I in practical voltage source. The output voltage decreases. Listen here. This is the graph for practical voltage and this is graph for ideal voltage source. In ideal voltage source, it is constant, it does not depend upon the current. For all the values of current, the output voltage is constant. But in practical voltage, the voltage will decreases if the current increases, right? So therefore the voltage depends upon the current produced by the voltage source. That's all about practical